to CS 1401, Video 7.1, Logical Expressions. We're working our way today toward conditional statements which help us control what happens in a program. And the thing that determines what happens in that conditional statement will be the result of evaluating a logical expression. In other words, we'll do this if something is true, and we may do something else if it's false, something like that. So for example, a logical expression might be, is a number even? So we have some arbitrary number coming in, we don't know what it is, but we need to know if it's even. So let's write an algorithm that describes this logical expression. So I've called my algorithm isEven. It takes one argument, which is the number, and it's going to return true or false. And here the idea is that I'm going to return the result of evaluating whether the number modulo 2 is equal to 0. That is, if I divide by 2 and I look at the remainder, that will either be 0 or 1. If it's 0, then the number remainder 2 is going equals 0 will be true, and otherwise it's false, and that's what I'll return. Now, just one note. In my pseudocode, I've used a single equal sign to indicate test for equality. That's not going to be the test for equality operator in Java, so be careful there. Now, for example, if I say something like isEven of 17, that should return false, and isEven of 2044 will return true. It's possible to combine these simple logical expressions into more complex logical expressions, and you can do that with and or. With and, every condition must be true, or else the whole expression is false. And with or, at least one condition is true, otherwise it's false. Let's take a look at an example. I might want to find out if a number is within a given range. So for instance, I might need my number to be between 3 and 7. That is, 3 is the lowest acceptable number and 7 is the highest acceptable number. And I need to find out if it's between 3 and 7. So here's an algorithm to do that. And I've called my algorithm isWithin, and it takes 3 arguments: the number we're checking, the lower bound, and the upper bound. And what I'm going to do is return true or false, and that's going to be with a compound logical expression. So what I need to do first is to see that the number is greater than or equal to lower bound, and second, that the number is less than or equal to upper bound. And if both of those are true, then I return true. Otherwise, my expression will be false and I'll return false. So for example, I could say isWithin 45, 0, 100. So 45 is my number, and 0 is the lower bound, and 100 is the upper bound. And my algorithm, when it evaluates the expression, the logical expression, will return true. In contrast, if I evaluate isWithin minus 45, 0, 100, that will return false because minus 45 is not in the range 0 to 100. It's possible to create even more complex logical expressions, and here's an example of a complex logical expression using OR. So I've created an algorithm with the not very helpful name of check2tests, by which I mean what we're going to do is check that the number is even or that the number is within our range. So it's going to take 3 arguments: the number, which will be either even or odd, and it'll also be or not be within the lower bound or the upper bound. what I'll do is return an expression that will evaluate to true or false depending on the values of the variables. So if is even the number is true because the number is a multiple of 2, then it will return true because it's OR. And remember that in OR, the expression returns true if either case is true. Or it will return true if the number is within the range. So, for example, if I say check 2 tests of 18, 45, and 55, which means we're seeing if 18 is even or if it's in the range 45 to 55, that will return true because 18 is even, and even though it's not between 45 and 55, the test is OR. So if either one of the conditions is true, check 2 tests is true. In contrast, check 2 tests of 19, 45, 55, which tests to see if 19 is even or is between 45 and 55, returns false because 19 is not even and it's not between 45 and 55. Finally, check 2 tests of 4, 45, 55, which means is the number 4 even or is it between 45 and 55, returns true because while it's not within the 45 to 55 range, it is even, and we only need one condition to be true in an OR. Let's take a look at another example, and here I want to see if a day is on the weekend. In other words, it should return true if our day is Saturday or Sunday, and false if it's any other day of the week. So I'll call my algorithm isWeekendDay, and it'll take one argument called the day, which is going to be a string with the name of the day in it. And all I'll do is return true if the day is Saturday or the day is Sunday. Now remember again that in my pseudocode the equal sign is the test for quality, not assignment. And not surprisingly, if I call isWeekendDay of Saturday, it should return true, and isWeekendDay of Monday will return false. How would I have an easy way to find out if a day is a work day? Well, I already have an algorithm for if something's a weekend day, so I can use that as the basis for an algorithm to check if something is a weekday. So I've called my algorithm isWeekday. Again, it takes an argument called the day. And what it's going to do is return false if it's a weekend day, and true if it's not a weekend day. So I say return not isWeekendDay of the day. So isWeekday of Saturday returns false, and isWeekday of Monday returns true. Here's another example of a complex logical expression. Let's say we want to determine if a movie is funny. So I'll create an algorithm called isFunny. Now, I'm thinking that a movie is funny if it has Robin Williams in it, and a movie is also funny if it has Bill Murray. So it's funny if it has Robin Williams, or it's funny if it has Bill Murray. But wait a minute, there are some movies with Robin Williams that are not funny. So for instance, Patch Adams is not a funny movie. I think any movie about dying children is not going to be funny. And Bill Murray also made some movies that aren't funny. In particular, I'm thinking of Lost in Translation, which is about a middle-aged man who's having a crisis of the self in Tokyo. So what we want to do is create a logical expression that will return true if a movie has Robin Williams in it, or the movie has Bill Murray in it, and where neither movie is Patch Adams or Lost in Translation. So that's a look at how to define and use logical expressions in pseudocode. In the next video, I'll explain how to implement these logical expressions in the Java programming language. See you then.